All right, algebra, we've made it to our final unit of the year. We're talking about rational expressions throughout much of this unit. So we're going to start with simplifying rational expressions. So simplifying is all about doing everything we can. So a lot of this is actually what we end up doing is we factor to cancel. So what I mean by that is because these are rational expressions where most of them are in fraction form, if we get the same thing on the top and the bottom, we can cancel those out. So if I look at my first example here, 6x plus 12 over x plus 2. I'm going to look and see if there's anything that I can factor. On the top, 6x plus 12, I could divide out a 6. So when I do that, if I take 6 out of each term, that becomes 6 parentheses x plus 2. And that's still over x plus 2. Now you can see I've got an x plus 2 on the top, and I've got an x plus 2 on the bottom. They can cancel out. And what am I left with? 6 over 1, because remember, if everything cancels on the bottom, that's just 1. 6 over 1, which is just 6. So this factors to 6. And basically the premise here is, no matter what I plug in for x, it's going to simplify to 6. Think about it. If I plug in 2, 6 times 2 is 12, plus 12 is 24. 2 plus 2 is 4. 24 divided by 4, 6. If I plug in 0, 6 times 0 is 0, plus 12 is 12. 0 plus 2 is 2. 12 divided by 2, still 6. No matter what, you're going to get 6. It's not going to change. So we were able to simplify that one to 6. Let's look at our second one here. 15b over 25b squared. This is actually, you've done this before in our exponent unit. But this one, I'm looking at 15 and 25. I could divide a 5 out of both of those. Also, I could take a b out of both because I got a b up top. I got a b squared on the bottom. So if you really wanted to think about this, I could take a 5b out. So so on top, it would be 3 times 5b. On the bottom, it would be 5b times 5b. Those can cancel. I end up with 3 over 5b. That step isn't really necessary on a problem like this. You can just look at it. All right, 15 and 25, I can divide out of 5. B and b squared, I can divide out of b. So when I take out a 5 and a b, I end up with 3 up here. On the bottom, I end up with 5b. All right, let's look at our next one. 12c squared over 3c plus 6. So when I look at this, I'm going to look at the top, 12c squared. Okay, that's just one term. On the bottom, I have 3c plus 6. Can I factor anything out of that? I can take a 3 out. So if I took a 3 out of the bottom, the top stays the same. The bottom is now 3, if I divide 3 out of each thing, times c plus 2. Now I can actually divide out of 3. These 12, I can take a 3 out of 12, and I can get rid of this 3. So when I take the 3 out of 12, that's 4c squared. On the bottom, that 3's gone now, over c plus 2. Now, this is where people say, oh, I got a 2, and I got a 4. And they think, oh, I could divide out a 2 of both. You cannot, because this 2 is not alone. It's with the c plus 2. That is one term, one component. So you cannot do that. You can only do it when it's something being multiplied. So when it's being added like that, you cannot factor those further. This is as far as we can simplify. There's nothing else we can do. We get 4c squared over c plus 2, and that is simplified. So let's look at our last one. 20 plus 4t over t plus 5. So I look at the top, I see, ooh, I could take a 4 out. I divide by 4, and now I've got 5 plus t. All of that over t plus 5. Now, we know with addition, order doesn't matter. 2 plus 3 is 5, 3 plus 2 is 5. Order doesn't matter. So 5 plus t and t plus 5, they're the same thing. So they can cancel out, and I just end up with 4. All right, so that's example 1. I got another video coming for example 2.